not only is it important to find the slope of the line, remember that we're talking about lines. We're talking about straight lines, what the slope is, what the y-intercept is, okay? What is the line, okay? Not only important to know what the slope of the line is, but it's also important to know how to graph that line, okay? So there's different ways that we can graph a line, an equation. So if I have an equation that looks like this, y equals x minus, how can I graph this? That's the question, okay? So one way to graph this line is to do a table of values, okay? So as you can see, in the table of values, I have values of x that I've picked for you, okay? And then in this case, I have the equation. I copied it. And then right here, it will be the points that I'm gonna end up with, okay? So the point is x, y. So the first one, x equals to -1. So what I have to do here is I have to replace that x value in where x is. Because my equation is y equals x minus 5. So if the first value of x is -1, so I have -1 minus 5. Do you see what happened?
Right.
So I replace that x with a -1. Are we okay with that?
Okay.
All right. So what's -1 minus 5?
-6.
Is -6. Okay? So you see right here that my x is -1 and my y is -6. So my point is -1, -6. Do you guys understand that?
Right.
So x is -1, y is -6. Are we okay with that? How many of you are okay with that? So 1, 2, 3.
That is x.
Yes.
Y.
Exactly. We're finding the value of y. Okay?
No.
So, same thing we have to do for this. The x value, I'm giving you that. If x is 0, so it'll be y equals 0 minus 5. So that is -5. So what's my point?
Right.
What's my point?
0, -5.
That's correct. X is 1. So y equals 1 minus 5. So that is -4. So what's my point here?
1
One.
and -4.
Negative. Okay? Last one would be 2. Y equals 2 minus 5, which is -3. So my point is 2, -3.
Yes.
So now I filled in the table with all the points that I have. Now I have to put these points on the graph and draw the line.
No, no, no.
Okay? So, -1,
Yes.
-6. We're okay with that? Locating the point, like that's what we did on Friday.
Yes.
Okay.
Second point is 0, -5. So it's right here.
Okay.
Third point is
1.
1, -4. And then 2, -3.
Okay.
You see that? They're following a line?
Yes.
Yeah.
Yeah? They must form a line because that's an equation of a line. So if I'm gonna graph this, just do that. Okay? And a line is continuous. Continuous means it never ends. Okay? So that's why we put the arrows at both ends. Okay? Because that line, I can stretch it all the way till the end of the page. Are you guys okay with this? Okay? So it's a matter of taking the equation the equation of the line, plugging in the value of x that I've assigned for you, and put them in. Now, there's no such thing as wrong x values. If let's say I did not give you these x values, you can pick any x values that you like. It's not going to be wrong. Okay? The y value is dependent, it depends on the value of x. Okay? But the x, whatever x value you like to pick. You want to start with 10? Go ahead. Okay? You want to start with 20? Go ahead. But you want to find room for it on the graph. Right? Because I don't have 20 here on the graph. Right?
Wonderful.
Are you guys okay with this?
Yeah.
Okay? Now, to look at this question. Is the point 50 on the line y equals x minus 5?
Yes.
And how-
Wait. Yeah, it is.
How do you know that?
Because I looked.
You've looked, you've extended, right? Maybe you extended that graph, right? You extended it. Oops. I'm kind of like, my graph is a little weird because it's not lined up properly because I'm using these pens. But for you guys, it might be more,
Yes. It's clearly there.
right? If I actually extend, you see that? Where's 50? Where's 0.50?
It's on the 5.
It's right here, right? That's 50.
That's it, you.
Right? So is 0.50 on the line? Yes. If I'm extending, I can see, yes, it is. Now, how do we prove it algebraically? That's the question. Yeah.
Change the value of x and put it as something else.
What do you put it as?
And
Why then? What's the point that I'm trying to test?
Change it to 5.
Change it to 5. You're testing the point 5. Right? You're testing this point right here. So if I replace this by 5, what should I get?
0. 0.
So is it true that it's 0?
Right.
Yes, it is.
Right?
Do you guys understand that? So I'm going to show it to you in a different way. Look here. That point should satisfy that equation, which means the left side should equal to the right side. If it is not, then this point is not on the line. Okay?
Couldn't
So-
you just see what goes into 5 and whatever goes into 5, an even number would be on that line eventually?
I don't know what you mean by that.
I don't know.
So it should satisfy this. So that means left side should equal to the right. Okay? So, what the 5 represents what letter? X or Y?
X.
X.
And the 0 represents?
Y.
Good. So I'm gonna plug them in here. Y is 0 equals 5 take away 5. 0 equals 5 take away 5 is 0. Right?
X.
Left side equals
Left-hand side.
right side. So that means the point is on the line. So therefore, 50 is on the line. Okay? So I tested it in 2 ways. First way, I extended my line, my straight line, I extended it, I stretched it to see if 50 falls on it. Okay? The more accurate way is to actually plug in the point into the equation and see if the left side equals to the right side. Okay? I'm going to give you another point. Let's see if it falls on the line or not. And the point is 10 fall on this line? What do I have to do? Does it fall on y equals?
No,
And how do you know that?
I extended it.
Now, I don't have 10 on my x-axis, so technically you can't extend.
I did it.
It won't be accurate. If I want to do it accurately, what do I do? Yep.
Put the 10 where the X is,
And then where would I put the 3?
where the Y is.
And then what should happen if it is on it?
Well, you go, you do the equation.
Okay, so 3 equals, what's 10 take away 5?
5.
Is
Then
3
you go-
equal to 5?
No, you have to do.
3 is not equal to 5,
So now
right? 3 is 3, 5 is 5.
Yeah,
They're not equal to each other.
Yes.
So that means the left side is not equal to the right side. So that means the point is not on the line. Now, look here. I got left side equals to the right side. That means the point is on the line. Okay? If you get that the left side is not equal to the right side, then the point is not on the line. Are we okay with this? Yes.
That's just a random form.
That's a random point I gave you guys. To prove to you, to show you what would happen if it's not on the line. Okay? Are we okay with this? Yes.
There is one concept in India I've seen in books,
Mhm.
line segment and array. Array. What's the difference? Line segment, we put a line of straight line
Mhm.
in my time.
So line segment
Line
is,
segment is what? What's the difference?
a line segment is a piece of the line. So if you're taking between this point and this point only, it's called a line segment. So it's a piece, a specific piece of a whole line. Okay? So if I'm taking this is called a line segment. It stops. It doesn't keep going. Make sense? An array keeps going. And okay?
These are new things, it has come in a math.
Mhm.
My time, it was not like only straight line.
Okay. Are we okay with this so far? Alright. Now let's look at another equation.
Yes.
Right? We're still doing the same thing, but this is a new equation. So the equation is y equals negative 3x plus 4. I gave you values of x. We're going to have to find the values of y. So all what I have to do is what?
Yeah, we put the value. Oh,
That's right. Plug in the value of the x. So y equals negative 3. Instead of x, I'm going to put negative 1. What's happening between negative 3 and the x? Multiplication. That's why I have to put the
That's
brackets.
what
And then plus 4.
yes.
What's negative 3 times negative 1?
Not 3,
Positive 3.
Yes.
So 3 plus 4 is
7.
7.
7.
So what's my point?
Minus 1,
Negative 1 and
7.
7. Are you guys okay with this? Okay. I would like you to finish this table and try to graph this line.